finance. There's like 4 sections: 5.1, 5.2, 5.3, and 5.4. Let me start by sharing my PowerPoint. That way you can have animation. Okay, so let me start by sharing my screen here with you guys. Okay, so let me start from the beginning. So here we go. This section covers again mathematics finance, and it's intended for students enrolled in 0324 and 1324. So the first topic that I'm going to cover is called simple interest, and the second will be compound interest, future value annuities, and present value annuities. The simple interest, I believe, is section 5.1, compound interest 5.2, future value annuities 5.3, and present value annuities 5.4. Okay, simple interest. What's simple interest? This is a formula for simple interest. I believe the book has I equals to PV times R times T, but I like to use INT because it's more, accommodates, the word interest in a better form, I believe. So that's why I like to use INT for interest. Okay, the way I like to set it up, students, is I like to put my INT equals, my PV equals, my R equals, and my T equals, right? Every variable that's here on the formula here. So then the interest, which is INT, is a fee paid to use someone else's money. Okay, that's interest earned. The PV is called the present value or principal. The R is going to be their interest rate. And this is always denoted by the percent symbol. Okay, it's going to have like a number and then the symbol. That means that's going to be your interest rate. But the interest rate is always put in a decimal. Okay, I'm going to show you later on. And the time is in years. Okay. So, and also this is also future value. The future value is equal to the present value plus the interest. So, for example, if you use somebody's money, right? Then use some money with an interest rate, and you use a specific time. So you're gonna pay back the money that you borrowed, which is a PV, right? And then plus the interest. That's where the future value comes in. But for the future value, there's another formula that we can use. Okay. So what's interest? Interest is PV times R times T, correct? So here we're going to use a little bit of algebra. So first, I'm going to factor out the PV, right? Because they have the PV in common, which is present value. You're going to factor it out. So what's left? 1 plus R times T. Because PV times 1 is PV. PV times R times T is PV times R times T. So this is a formula for future value. Okay, that's a formula. And what does it mean? The future value is the sum of the principal and the interest earned. The present value is the same as the other formula, the present value or principal, same interest rate, and time is in years also. Well, let's do an example. Okay, first of all, this is what you need to know. If the months are given, then time equals given months divided by 12. This is a common mistake that students make because they don't give you the time in years. They might give you the time in months, like say 6 months. And then instead of, they will put here 6 for the T, which means 6 years, but it's not true. Okay, so if they give you months, you divide it by 12. It's going to be the given months divided by 12. And the interest rate must be in decimal. Okay, so for example, 5% equals 2.05. You're going to move the decimal place 2 places to the left and take away the symbol. Okay, now, here's an example. Example 1. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle. How much interest did Martha pay? So right away here, guys, the key word that we're going to be using simple interest, this formula is the word here, simple interest. That means we're going to use the formula that we just covered. So here you have 2 options. Okay, which formula should we use? We can use the first one that I went over, or the second one. Which one should we use? It doesn't matter, guys. Okay, I'm going to show you both ways. Does it matter? No. Okay. So let's use this formula first. Okay, but but remember, what are we looking? What are we looking for? Is find the total amount that Martha paid to her uncle. So we're looking for the future value, right? So we're looking for the total amount. If you use this formula, then at the end you're gonna get the interest plus the present value to get the future value. Okay, but it doesn't matter which one you use. Okay, if you use the one on the left to find the interest, you're gonna put int equals, pv equals, r equals, and t equals. And then you're going to begin extracting the information that's given to fill out the ones that are known, and there's always going to be only one unknown. So for example, Martha borrowed 12,000, so that's going to be your, right, your present value. See, they turn green, the ones that are crucial here. So the present value is 12,000. The R is 3.5%. But they went into a decimal, so you're going to move the decimal place 2 places to the left, and you take away the symbol. And the time is in years, so the time is good. It's going to be 5. So all we do is plug it into the formula. Right, there's my present value, my interest rate, and my time. And use your calculator, and you got your response. So it's going to be 2010. Okay, now if we use a future value, okay, here, guys. If we want to use, right, so we use this formula here. So now we're going to use this formula to find the future value. Because future value is equal to present value. What we got here, what the value that you borrowed plus the interest. That's my present value, and that's my interest that you got to pay extra. So the future value is 14,100. How much interest did Martha pay? Total Martha paid, right, was 14,100. Interest paid, right, is going to be 2,100. Okay, now simple interest continues. Now let's use the other formula. Okay. So now we're going to use the future value simple interest formula. So again, we're going to put everything here on the left, and they're going to be extracting the information. There's my present value. There's my interest rate. And there's the time. So plug into the formula, present value, 1 plus 0.035 times 5, right? Because that's my interest rate, and my time is 5. So here we get 14,100, right? So this is the total amount that Martha paid. Now, how do you find the interest that she paid extra? So we subtract the future value minus the present value. You see, guys, so it doesn't matter which formula you use. Okay, now, students, throughout the semester, I always try to engage with students, for them to participate in my class. And it's like funny that every time that we get to chapter 5, when it comes about money, and then I give them real life examples and stuff, they are engaged. If I didn't get them to engage, during the first few weeks, when we get to money, they're engaged in chapter 5, because I believe we're in school to make money, right? This chapter is going to teach you how to, when you purchase a house and stuff like that, how much interest you'll pay, and is it worth it to buy a house at a certain price and stuff like that, or buy a car, or you want to save money for your kids to go to college. This chapter is going to cover all that. Okay, now let's do another example here. Mariana will need to pay a tuition bill of $7,500 for her daughters in 10 months. What dollar amount can she deposit today at 1.5% simple interest to have enough money to pay the tuition? So again, right? So again, here's the key word, simple interest. So I'm going to put my V equals my PV, my R, and my T. So I'm going to extract the information. Okay. Mariana will need to pay a tuition bill of $7,500, right? So this is in the future, right? Because it's in 10 months. So this is your future value. Okay, what are we looking for? So we're looking for future value. Present value. But this is your future value, what's given. Okay? Because again, guys, they say that what dollar amount can she deposit today, right? So that's what we're looking for. but this is the future value because it's in 10 months from now. And again, the interest, I mean, the interest rate is always the easiest one to find because it has a symbol. And the time is in months, right? So it's going to be 10 divided by 12. Here, guys, you don't need to simplify it because you're going to plug it into the formula anyway. But if you want to simplify it, this will be 5 over 6. Okay, but just leave it like that. So again, if we're looking for a present value, right, here we divide both sides by 1 plus r times t. So this is a formula that we're going to use. Okay, so again, my future value is 7,500. And here we have 1 plus my interest rate plus times my time, right? The time in years, but this is 10 months. So if you plug that in the calculator, guys, right, we're going to do this first, right? And then we divide the 7,500 by what we got in the denominator. So that's your answer. Okay, now it's $7,422.68 because you are down to a nearest penny. Now, guys, I'm going to show you another formula because a lot of students have trouble with this right here. So let me show you how we can use a calculator and just keep it with this formula here on top, the future value formula. Okay, so you're going to plug everything in. Okay, we plug everything in. Here, guys, we're going to use the inverse key. Okay, I'm going to show you how it looks like in the calculator. Okay, this is for a TI-83 or TI-84. So first, you can enter, right? We're going to enter 1 plus, just the way it is here in parentheses and everything. 1 plus 0.0125 times 10 divided by 12 and then close parentheses. So you should get 1.0104166667. And then you can hit this means the inverse key on your calculator. Okay? Let me see where it's at. The inverse key, it's it's on your first column on the fourth row. All right? Again, it's in the first column, fourth row. So you're going to hit that, and then you're going to enter. When you press on the inverse key, you should see answer to a -1. That means inverse. Then you enter the 7,500, and then you get your right, and then you get your answer. Boom, there it is. This way, because a lot of times students they don't want to use too many formulas. So these two formulas eventually are the same formula because on the future value, all you do is divide by PV, right? You divide by 1 plus R times T to both sides, so this is what you get. But a lot of students, when they're beginning math at the college, they have a hard time using the calculator. You know what I'm saying? So this way here, guys, is how I'm going to be showing you from now on. To use the inverse key. And if the instructors want you to show the work, well, you're showing this right here, okay? Because they should kind of write. Because when I give this in an exam, the most important thing for me is the setup. If you know how to extract the information, because it's not fair to actually deduct a lot of points from a student that doesn't know how to use a calculator. So that's why once they have the setup here, right, I will give them say it's worth 10 points. I will give them like 7.5 points or 8 points just for the setup because they know how to set it up. And then the other 2 or 2.5 points comes from the actual answer. But like I said, every instructor is different, okay? But you have to accustom to your instructor. But this is what I would do. Okay, now let's do another one here. Let's see, example 3. John received $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was 125? So here, guys, what are we looking for? Okay, which formula should we use? Again, right, it says here, let's see here, John received, how long was the loan for? So here, guys, we're going to be using this very same formula, okay? But how do we know, what are we looking for? We're looking for how long, right? How long was the term? So we're looking for time, right? How long means time. So then we can either use that one or the int equals to PV times R times T, or the FV equals to PV 1 plus R times T. So because we're looking for time, right, we can use this one because check this out. John received, that's how much John received for his aunt to buy a car, from his aunt to buy a car. His aunt charged him 2.5% interest. So this interest is my int, right? Because that's how much extra he's going to be paying. what's given and what to look for. Again, I just explained that. So here, we're looking for time. That was how much, the loan was for. It was at 2.5%, which you have to convert it to a decimal, equals to 0.025. And the interest, right, that accrued was 125. That goes there. So we just plug into the formula. Plug everything in. There's my interest accrued. There's my my present value or the money for the loan. This is my interest rate. So we're looking for time. So here, right, we multiply 10,000 times 0.025, so we get 250 T. Now we just divide by 250. The answer is 0.5. So how long will it take? Half a year, or 0.5 years, or half a year. That's your answer. Okay, now I believe this is it for the simple interest. Now let's do compound interest. I'm trying to give you like at the most 3 examples of each one, because we only have like 50 to 60. 50 minutes to like an hour, and then I want to go over, and because they told us to more or less do about an hour. That's how much this happy hour is. Okay, so for the compound interest, this is a formula for compound interest. Or if you notice, these 2 formulas are the same. There's my future value. There's my present value. There's my 1 plus R divided by M. This, the I, will represent the R divided by M, and the N will be the same thing as M times T. I like to use this formula instead of this one here, because this is less numbers to work with. Okay? So now, what does the future value stand for? Okay, but even if you want to use both formulas, you have to find the R, the M, and the M and the T, right? So here the I is equal to R divided by M. But let's go in order. It's always going to be 7 things, guys. Okay, there's 1, 2, 3, 4, 5, 6, 7. Just remember, it's going to be 7 things or seven variables that you got to find. So the first one is called FV, means future value, future or maturity value. Again, the present value. PV means principal or present value. The R means interest rate period, convert to decimal, right? I already mentioned that. This is new here, guys. This is the only thing that's new. The M, the I, and the N. The M stands for number of compounding periods per year. Okay, right now I'm going to show you what that means. Well, that's what it means, but I'm going to show you examples of how to know what the M represents. The T is number of years. Okay, now the I is the R divided by M, the interest rate per period. The N is M times T, the total number of compounded periods. That's your N, okay? So here we go. So these are compounded keywords, okay? So the words are going to be on the left, and the M means what the word means, okay? These are going to be on the word problem. For example, yearly or annually means 1. So if it says compounded yearly or compounded annually, it means the M is equal to 1. If the problem states bi-yearly or semi-annually, then M is equal to 2. Quarterly, M is equal to 4. Monthly is going to be 12, because there's 12 months in a year. Weekly is going to be 52. There's 52 weeks in a year. And daily, guys, is going to be 360 or 365. If it doesn't specify that it's 360, then go for 365, because it's 365 days in a year. But at times, the book wants you to use 360, okay? So if it doesn't say to use 360 for daily, then use a 365. And then comes continuous. Continuous means without stopping. That means it's a very different formula. So instead of this formula see up here, it's going to be something different. And I will go over that one later, okay? So this is very crucial, guys. So when you're doing your homework, your assignments, you can get a copy of this or try to write this down on a notebook and stuff, because this is what you're going to be needing. This is crucial here for the next 3 sections, okay? Compound interest can be used to invest a certain amount of money without depositing additional money. Hey, guys, so this formula here, an example, how do we use it, okay? Let me show you like a quick example, so maybe it can relate to you guys. Say that I have some extra money there. Here at my house, I have like $10,000 just here in cash, and I want to make a little bit. Like a little bit of extra money. So I go to the bank and I want to deposit it, right? So I can get interest. Extra money. So then I just tell the bank that I want to deposit this money that I have just there, and I want to see how much I can get in, say, in 3 or 4 or 5 years. So with this formula, you're not going to put no more money per month, because the other ones are the ones that you're going to be depositing payments every month, every quarter, or every year. But in this one, you only put the money that you have, and that's it. And you let it, and then you just sit back and let the bank make a little bit of money for you. Okay. Example: you deposit $1,000 in an account at your bank that pays 6% compounded quarterly. 6% interest compounded quarterly. How much money will be on your account after 5 years? How much interest did you earn? Okay, this is an example of what I just went over, right? So you have, say that I had this much money just sitting around in my house, so I want to put it in an account. The account pays 6% interest compounded quarterly. How much money will be in the account after 5 years? And how much interest did you earn? Okay, so then there's my formula, right? So I'm going to put those 7 things that I told you to put, right? This is easier to put in the calculator. That's why I like to use this one. But these are the 7 things, right, that we need to find out. Okay, I jumped again a little bit. Let me go back. So here, so what are we looking for? How much? It says how much money will be on your account after 5 years. So we're looking for the money in the future, right? How much will it be in the future in 5 years? So we're looking for future value. Then the $1,000 is the present value. The present means the money that you're going to deposit right now. And then the interest rate is 6%, right? Because remember I told you that's the easy one because it has like a symbol there, the percent symbol. But you actually put it in a decimal. So move it to the left two decimal places, and you drop the symbol. Now the n, here's where the n comes in, right? Compounded, how many times is it compounded? So compounded quarterly means 4. And then how much, let's see here, and then the time is 5 years. So then I'm going to apply the I, right? It's going to be R divided by M, 0.06 divided by 4. Hey guys, here, at times, it's a little bit tricky here, guys. If you have like a finite number, right? That ends. I mean, actually ends like a real nice number. That's what you plug in. But at times you're gonna get something like 0.0113333333, right, without stopping. Do not round out, guys, because at times they want you to round out to your nearest penny, and if you round out here, it's gonna mess everything up. It's gonna mess up your answer. Okay, because my math is real sensitive. It wants it how round it out to your nearest penny most of the time. So since this number is real nice, right, that's what I'm going to be using. But if not, I will use the whole 0.06 divided by 4 for the I. Okay, but since this number is real nice and finite, that's what I'm going to use for my I. And my n is going to be 4 times 5, right? Because it's going to be the n compounded quarterly is 4, and the time is 5 years. So 4 times 5 is 20. So there's your formula, guys, right? So future value, there's my present value. There's a 1. There's my I with a 0.015, and my n is 20. So all you do is put it in the calculator just the way it is. So that's your answer. But you have to round out, right, to the nearest penny, which means this is the nearest dime, and this is the nearest penny, right? This is a tenth, and this is a hundredth. So the future value will be 86 because it will go to the third decimal place, and if it's 5 or more, you add 1 to the tenth place. That's why it's going to be 0.86. So after 5 years, there will be $1,346.86. So how much interest did you earn, right? So we're going to subtract the money that you put in at the beginning, subtract it from the total in 5 years to get your interest earned. So it's going to be future value minus the present value. So there's how much interest you earned, how much money extra you earned. Okay. And students, I believe also, guys, this is being recorded. But at the end, I have a PowerPoint that the original PowerPoint that you can ask for. I mean, even put my email there and send me a message, and I can send it to you. This way, you can actually, go at your own pace. The way I do my PowerPoints is that for no student to fall behind, because at times there are students that haven't been in school in a long time, like 10, 20 years, and then they come to take finite math and they really struggle. And this PowerPoint, I did it and taking into consideration all those students, the students that are not up to standards, or students that have been away from school in a long time. So this will accommodate you in a real nice way. Okay, so again, if you want the PowerPoint, just send me an email and I'll be able to send it to you. Continuous compound interest, right? Okay, now this is what it says here, guys. But here, guys, remember what I said that compounded continuously, it was a different formula. So the word continuously means that it's not the same formula that we use on example 4. It's going to be the one that has compounded continuously, right, without stopping. So then this is the formula that we're going to be using. So here, guys, there's only future value, present value, the R and the T. So there's only 4 things that we have to worry about. That's it. 1, 2, 3, 4. So now let's extract the information. You deposit $1,000 into the account, right? So this will be your present value, because that's the money you deposit right now. The interest that you're being paid is 6%, right? So it's going to be 6% converted to a decimal, 0.06. And the time is 5 years. Since it's compounded continually, there's no value for the M, right? There's no M here. So all we do is plug into the formula. Very, very simple, right? So there's my future value, my present value, VE, and this is a 0.06 times 5. Okay, now, it's always wise to put parentheses here, guys. To be safe, put parentheses when you put here. Because when you hit the E function or the E key on the calculator, it's going to give you like a caret, like a little arrow, like a little caret, and then you're going to put the 0.06 times 5. But if it doesn't give you the parentheses, which most of the calculators they don't, most students put 0.06 and then they multiply by 5. You're going to get the wrong answer, because what it will do, all the calculators follow PEMDAS, which is the order of operations. What it does, it will multiply 1,000 times the E and then times to the power of 0.06, right? And then you multiply all that by 5, which is wrong. So that's why, to be safe, you put this in parentheses right there. Okay? So once you put in the calculator, guys, this is your answer. So again, right, we have to round out to our nearest penny. So this is 8. So we're going to add 1 there to the 5, which will give us a 6. So that's the future value after 5 years. Okay, now, so how much interest did you earn? Right, so again, the same formula as before. For the interest, it's future value minus present value. So it's going to be 1349.86 minus the 1,000 that you put in. So that's your interest that you earned. Okay. Okay, now let's see this one here. I want to earn, this is example 6. I want to be earning an annual salary of $100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year. And the starting salary is negotiable. What salary should I request in order to meet my goal? Okay. So again, we're going to use the compound interest formula. Okay, so in my opinion, it's better to use this one here. But now, what are we looking for? Okay, again, easier to put in the calculator. So again, remember, guys, it's always 7 things. So here, guys, we're looking for the present value, because how much money should I request right now, right? It says here. I have been offered a job that guarantees an annual salary increase 4% per year, and starting salary is negotiable, right? So you want to know the starting salary that you should ask for right now. What salary should I request in order to meet my goal? So we're looking for the present value. What salary should we ask right now in order to get 100,000 in 15 years, right? So this is all about future value. So then my future value is 100,000. My interest rate is going to be 4%, which is 0.04. My M, let's see, annually, right, is going to be 1, right? Because earning an annual salary, so that's why it's 1. My T is 15 years. So then what's my I? R divided by N is just 0.04, right? So that's real nice and finite. So I can put that in the calculator. I mean, to replace the R divided by M. And N is 1 times 15, which is 15. So again, we plug everything in, right? There's my future value. The present value is what we're looking for. My I is 0.04 and my N is 15. Okay, now, so you're gonna put all this in the calculator, right? Let me see what it is here. Divide both sides by 1.800943506, and again, you don't round out. So that's my present value. We use a calculator, so this is going to be my answer. So it'll be what, 55,526 and 45 cents. Okay, now again, I'm showing you guys, right? With the calculator, without stopping the calculator, without stopping the flow of the calculator. So we're going to go straight from here to here in the bottom. So again, okay? Because here, guys, you have to stop and clear the calculator. That's why, right? So you divide, so you have to stop. And I'm going to do like I did earlier and use the inverse key. Okay, I'm going to input 1 plus 0.04, right, to the power of 15, everything like this in the calculator. You should see 1.809435506. Then you're going to press the inverse key, which is the x to the -1. Once you do that, you should see answer to a -1, which means this answer, I'm going to take the inverse of that. Then you enter 100,000. Then you see the answer here, guys, and then you see we get the same answer as what's here. Then you round off, and you get the same value, $55,526.45. Formula used by the book is this one here, right from the beginning. Okay, but to me, guys, like I said, as experience as an instructor and also as a student, when I was taking this course, to me it was kind of hard to use this formula here because I had to write everything down, all those numbers down, and at times it would be a lot of work. For me. And then when I became an instructor, I found out that it was easier to use a calculator and do it in this form. So that's why you can do it in both forms. This is showing all the work. Some instructors might want all this, okay? So you do how the instructor wants it. But this is the easy way, or to check your work in the calculator. Here, if you use it this way, you don't have to stop the calculator, guys. It's an easy flow. Okay. And from now on, I think I'm going to be using this way. From now on. Okay. Now that was it for section 5.2. Now comes section 5.3. Section 5.3 is future value of an ordinary annuity. Hey guys, this formula is to let me give you an example here. Say that you want a certain amount of money in the future, but in this formula you're going to be putting payments every month or every quarter or every year, okay, to accumulate what you want. Okay, right now we're doing an example, but that's more or less how this formula is used. Okay, it's called the future value of an ordinary annuity. So again, all these formulas required 7 things, right? There's 1, 2, 3, 4, 5, 6, 7. And these two formulas are the same formula because again, my R divided by M is the same thing as my I. And my M times T is the same thing as my N. That's why we have the same procedure as the previous chapter, previous section. Okay, future value of annuities can be used to accumulate funds for some time in the future. You must set regular deposits during the specific time. That's what I mentioned earlier, guys, that you have to put in extra payments or deposit extra money every quarter, every month, every year. That what it means here by a specific time. Examples. Let's say you can afford to save $1,000 every month and you want to set up an annuity to make interest on the account. That means, guys, say that you have a job and you make a lot of money that you can afford to save $1,000 every month. So you can set up one of these future value annuities. Okay, so that's what the example is talking about. Okay, you can save $1,000 every month, and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of 20 years? Okay. Second example, let's say you are planning on sending your just born child to college when he or she turns 18. Because when when uh, when you finish school, right? Because we're in school to make money, right? To have a better job and to make money. More than likely, once once you finish with college, you're gonna get a job which your family or your kids are not gonna be able to get financial aid because more than likely you're gonna be making a lot of money. So more than likely your kids will not qualify for financial aid. So it's always wise to begin setting up some kind of account. Okay, so let's say, so there's an example here. Let's say you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure you have enough money in 18 years for your child to attend college. Okay, so I believe I'm going to show you these two examples right now. Okay, there's this one here. Okay, example 7. Again, you can afford to save $1,000 every month and you want to set up an annuity to make interest on the account. An investment company offers 3% interest for 20 years if you deposit $1,000 at the end of every month. How much money will you have in 20 years and how much interest will you earn? This is similar to the one about sending your child to college, okay? But let's do this example first. So again, that's my formula, okay? So again, there's 7 things. So now you're going to begin extracting the information, okay? Let's see what we're looking for. You can afford to save, right? How much money will you have in 20 years? So we're looking for the future value, right? Because we're looking for how much money will it be in 20 years. So that's what we're looking for. So then the $1,000 is your payment. Let's see here, the interest rate is going to be 3%. You want it to a decimal, so it's 0.03. My M, every month, right? So my M is going to be 12, right? Because every month. Let's see what else is here. My time is 20 years. Now, what's my I? 0.03 divided by 12. You see, guys, it gives me like a nice finite number. Now, my N is 12 times 20, which will give us 240. Now all we do is plug everything in. Okay? Now, how do we do it in the calculator? Okay, so first of all, you're going to enter, you take it in steps. What I did here, I did the numerator first. The parentheses 1 plus 0.025 to the 240 minus 1. Okay, so then I divide that by 0.025 without stopping. And then I multiply it out. So that's what I get. Okay, so it's going to be rounded out. 32, what is it? $328,302. Okay, now again, how to use the calculator without clearing or stopping. Again, I'm going to show you again, like I did earlier. Here we go. Okay, what do we do here? You input 1 plus 0.05 to the 240th power minus 1 in your calculator, just the way it is here on top. Then when you enter that, you should see it on your screen. And then you're going to press the division right because you're dividing the numerator by the denominator by what we just got by 0.0025. Then you should see answer divided by on the screen. That means that this answer is being divided by that's what you see on your screen, and then you enter 0.0025. Then you should see 328.3019981 on the screen, which that's what we got here. And then you're going to multiply that, press on the times key, they're going to multiply that by 1,000, right? But here it's showing you what you see on your screen every time. That way you cannot go wrong if you follow my steps here in green. And then you get the same answer as what we just did. This is without stopping the flow of the calculator. At times students stop it and they do all these steps. But here tells you how to do it without stopping the calculator. So how much money did you invest? Okay. So again, how do we find this? How much money did you invest? So how many payments are there? 240 payments, right? So there were 240 payments. And how much were you paying a month? 1,000, right? So 240 payments times 1,000. So you're gonna get, so that's how much money came out of your pocket, 240,000. So how much money did you get in interest, like free money? For putting the money into the account, how much interest did you earn? So we subtract the future value minus how much money we put in. So you got $88,302 extra. Okay, that's how you use these type of formulas. Okay, and 3% at this time is even a little bit high, because nowadays I believe they offer like 1.5%. I've seen it like 2.8%. But back in the 80s and 90s, they will give you like 9%. That was a lot of money. In interest at 9%. But now this is probably the max that you're going to be getting. Okay. So now, future value. Okay, let's do another example. Here we go. Oh, there's a one about sending your kids to college. Okay, you are planning on sending your just born child to college when she turns 18. Say you had a girl. You want to have 250,000 in an account for tuition in 18 years, because tuition is growing, guys, and then more likely in 20 years from now or 18 years from now, it's going to be really expensive for college tuition. How much money must you deposit at the end of each quarter in an account paying 5% compounded quarterly? Okay. So here, guys, we want to get this much money right in 18 years. So again, let's use the formula because it's easier. Again, there's those 7 things. So what are we looking for now? How much money must you deposit at the end of each quarter, right? So we're looking for the payments. So we want 250,000 in the future, right, in 18 years. So that's your future value. Now the interest is going to be 5%, which is 0.05 in the decimal. Compounded, right? So compounded, let's see, compounded quarterly. So quarterly stands for 4. The time is 18 years. Now let's do the I, right? The R divided by M. 0.05 divided by 4 gives us something real nice and finite, right? So it'll be 0.0125. And 4 times 18 will be your M, which is 72. So let's plug everything in. Okay, now guys, here's a good example why I show you how to use the calculator without stopping, because these at times these can be real time consuming, and this will take maybe like a whole paper to work out. Okay, but again, you do what your instructor says for you to do. If they say that they want to see the work, well, then do step by step. But anyway, here I'm going to show you, but I'm going to show you also without by using the calculator. Okay, input, right? So you can input what's in the numerator, all this on top here. The parentheses 1 plus 0.0125 plus parentheses to the 72nd power minus 1. So you should see that on your screen. So if the instructor wants you to show the work, well, then you rewrite this problem again and put everything out, and then just enter 1.45920.268 on the numerator here on top, and then divide it by 0.025. Okay, now then here, guys, you're going to press right the division because here you're dividing. Then you should see that on your screen. Then you're going to enter 0.0125. When you do that, you should see that on your screen. 115.6736.215 on the screen, right? Now, if the instructor wants you to see that work, well, then you rewrite the same problem again, and then you're going to write 250,000. The PMT thing, you're going to write times that right there. Okay? So then here's, guys, is where we're going to hit the inverse key. And again, the inverse key is located on the first column on the 4th row. Okay? On the TI-83, TI-84 calculator. So you're going to press the inverse key, and this is what you should see on your screen. And again, guys, I'm guiding you that way you don't think that you're doing it wrong, right? Because I also tell you what you should see. Then you can enter 250,000, and that's your answer that you should see. But you round it off, right, to the nearest penny. So since thousands place is 3, so this stays at 0.25. So that's how much your payments should be. Okay, 2,161 and 25 cents. So now, extra information. This is extra information, right? So how much money did you put into the account? So you multiply the payment times the number of payments, which is 72. So you get 100. So you get 155,610. So then, how much money extra? This is what you actually came out of your pocket, and whatever's left after we subtract this from the 2,161, that's how much money extra you're gonna get. So again, 155,610 came out of your pocket. So how much interest did you earn? So we subtract 250,000 minus 155,610. So about 94,000 came is extra money that you earned in those 18 years. If you want, divide that by 12, not by 12, divide that by 18, and that will tell you how much money you got per year. And then you want to do it by month, then you divide that by 12, and it tells you how much extra money you're making more or less per month. Okay. So again, 94,390 came from earned interest. Okay, now let me go back. What we just covered was 5.3. Now comes 5.4. 5.4 is my favorite because most of us, we go to school, right, or we have a job because we want to buy a house, or we want to buy a nice car, right? So this is about buying something, right, at a certain right, once you qualify, and then see if you can afford the payment. So all these formulas you'll be able to use when you go to buy a car or to buy a house. Okay. So again, there's 7 things. But now again, the I replaces the R divided by M, right? And N replaces the N times T, as is over here. So the formula, this is a formula that I like to use. Okay, so again here, most common use of present value of ordinary annuities are for purchasing expensive items such as a vehicle or house at the present time and making equal payments, including interest for a certain amount of time and years. Okay. Examples. You want to purchase a car. What are the monthly payments and how much will you end up paying? You want to get an idea on the process of purchasing a house. Okay. Key factors of purchasing on expensive items and payments. You must have a job. You must have good credit. The higher your credit score, the lower your interest rate you will get because you're like at a lower risk. You're like at a low risk from the bank that you're actually going to pay the payments. When your credit score is kind of low, it means that you don't have enough credit, or maybe you have bad credit, or maybe then the bank will might take a risk, but they're going to increase the interest rate. Okay. And also, guys, when you're going to get a house, you must get pre-qualified, okay, for the maximum amount of a loan, because you don't want to be looking for a real expensive house and at the end you can't afford it, right? So what you do first, you get pre-qualified, and then the person from the bank or the loan officer is going to tell you, right, he's going to run like a credit score. Even if you're buying a car, same thing. They're going to check your credit score, and then they're going to try to get you the best loan for you, okay, through a bank. So first you get pre-qualified and see how much of a car or how much of a house you can buy. So if you're qualified for 100,000, don't look at houses that cost over 100,000, because then when you look at the ones that you can buy, you're going to like them because you looked at better houses. So always you get pre-qualified first, okay? So let's do an example here. You buy a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? How much interest do you pay? Okay, so there's the formula. So let's try to plug everything in for the seven variables here, right? So we're going to be plugging them in, and then there's only going to be one variable that's unknown after we plug everything in. So you buy a car that costs $26,000, right? So this is how much the car costs. What are the monthly payments if the interest rate is 4.2%? and the loan is for 5 years. How much interest did you pay? So here, guys, this is, we're looking for the payment, right? So here, this is going to be the present value. This is how much money the car costs. So this is how much money you're going to borrow from the bank right now, right? That's why that's the present value. And here is the key thing, what are the monthly payments? So then, let's see, my interest rate will be 4.2%. It'll be 0.042. The time is 5 years. I mean, the time is 5 years, but on cars, guys, and houses, it's always like monthly payments. So most of the time it's going to be 12. Okay. And the time is 5 years. So what's my I, right? So R divided by M, you see, gives us something finite, something nice. And my M times T is 12 times 5 will give us 60. So all we do is plug everything in the formula. But here, guys, it's always wise to use this formula, because the other formula from the book is going to be, right, when you're looking for payment, is going to be the present value divided by all this right here. That'll be the payment. And to me, that kind of looks kind of intimidating for the students. So again, you stick to the same formula. And then here, guys, when you're looking for the payment, you always use the inverse key when you're looking for the unknown here. Okay. Now, let's see how we're going to do it. Again, we're going to do it. How you're going to input in the calculator. You're going to enter the numerator how it is. 1 minus parentheses 1 plus 0.035 close parentheses to a negative 60. You should see 0.1891185.031 on the screen. Then you're going to hit right the division. You should see the answer, right? It should see answer divided by on the screen. Definitely see it on black on the screen. Then you're going to enter 0.0035. After you do that, you should see 54.038502 on the screen, which is all this value here, guys, is a 54.03385802. Now you're going to press on the inverse key. Okay. Once you press on the inverse key, then that's what you should see on the calculator on your screen. Then you're going to enter the 26,750. So that's the answer, guys. But you have to round it out to your nearest penny. So it's going to be that goes to 6 because this is 5 or more. So those are your monthly payments. Okay, now. So how much money did you end up paying? Hey guys, even though this is how much your car costs, but the bank is gonna make some money out of you, right? Because they're not gonna give you. You're gonna end up paying that. You're gonna end up paying more. How much more did you end up paying? Let's find out. So how many payments did you make? 60, right? For $495 each. So you multiply those. So it gives you it's 29,703.60 cents. So that's how much you end up paying. Okay. So how much extra did you pay? So you subtract what you end up paying minus what you originally borrowed, which you paid about almost $3,000 extra. Okay. That's how the banks make their money. Okay, by charging you the interest, guys, right? So you end up paying a lot more. But if you can make extra payments every month, this will go down. You won't end up paying that much money. I mean, you should end up paying money, right? But not as much as almost 3,000. Okay, now I believe I have one more slide here. I did the examples, guys, on buying a car and buying a house because that's our ultimate goal as human beings, right? Is to have a real nice house and to have a real nice car. Okay, now, hey guys, when I teach these courses, like I get real life examples from the students. Like I told a student, and I remember this one because somebody said that they want to purchase a house for like $325,000. So that's where I got this example from. Okay, so this student, okay, say you want to purchase a house for $325,000. That'll be a real nice house here in El Paso, like a real nice one, with a 30-year fixed rate. Most time, guys, for the houses, it's 30 years or 15 years. Those are the most common ones. But if you end up paying extra every month on the principal, you can pay your house a lot quicker too, and pay less interest. Okay. So now let's do this example. You want to purchase a $325,000 house with a 30-year fixed rate at 3.9%. What are your monthly payments and how much interest did you end up paying? It's always wise, guys, to know what your monthly payments are. Okay, see if you can afford the house. But before you purchase a house, you have to get pre-qualified. So this person got pre-qualified, and she actually got qualified for that. I mean, for that amount. So again, that's my formula. So there's the 7 things, right? So this is you want to purchase that, right? So in other words, guys, you want to borrow this much money right now from the bank. So this is your present value. And we're looking for the monthly payments. So what are we looking for? Monthly payments. And that's the money that you borrow right now from the bank, that you want to borrow right now. So my R, right, our interest rate is 3.9%, which will be 0.039. And again, like I said, most of the times, the end is going to be 12, right? Because it's always in monthly payments, or most of the times in monthly payments. So M is 12. The time is 30 years. It's going to be, the I will be R divided by M, 0.039 divided by 12. Again, it's giving you something real nice and finite, 0.00325. And the number of payments will be 360. Okay? So let's plug everything in. Let's see, guys, how much the payments are going to be. But also, before the payments, guys, you also have to take into consideration the taxes for the house. That's extra. And the nicer the place that you live at, like the east side, west side, whatever it is, that the nicest place in town, the more the taxes are higher. Okay. So anyway, again, I'm going to show you how to use it in the calculator. So I'm going to input 1 minus parentheses 1 plus 0.00325 close parentheses, so a negative 360 in the calculator. And that's what you should see. Okay. After that, I'm going to press the division, and this right press on the division key. Then this is what you see. The answer divided by on the screen. You're going to enter the 0.00325. You should see 212.0134431 on the screen. So the 212 point, and the decimal is all this right here, guys. That's what we just did. Now you're going to press on the inverse key, right? Because the inverse key, guys, means like the inverse of multiplication, right? The division. So really, what you're doing is dividing both sides by this. That's what the inverse key means. That you're dividing both sides by that right there. Okay, but in a sense, you're multiplying by 1 over 212.0134431. That's actually what the inverse key is doing. And then after that, right, you enter the 325,000. So this is what you get, guys. So the monthly payments are going to be like 1,532.92. So those are the payments. Hey, guys, it's not bad, right? For a house. For this kind of house, the payments are not that bad. Because right now, rent, there's houses that are being rented for like $1,000 a month, and the houses are not that nice. So this will be like, if you can afford it, this will be like a good investment. So how much money did you end up paying? So we multiply that 360 times the payments, which gives us $551,851.20. So how much was it that you end up paying extra? You see, guys, so you end up paying like almost $250,000 extra, guys. So you end up paying $226,851.20. How can you eliminate that much interest paying extra? Is by actually giving extra money to the principal. So when you make the payment, you call the bank and saying that you're gonna put extra money, that you want it to go straight to the principal. And the more money that you can afford, pay it to the principal, and you'll end up paying the house in less than 30 years, and you'll end up paying much less than what you end up paying extra. Okay. Okay, now guys, that's it for this presentation. And like I said earlier, if you want the original PowerPoint, send me a text at aisasi@epcc.edu. and I'll be able to send it to you guys. Okay, let me stop sharing my screen.
Thank you very much, Mr. Isasi, for this presentation. Also for the audience who for assisting. I just want to remind you guys that we're gonna have our TBEs next week. Hopefully, you can also join us on then. Also, just to let you know, if you have any questions or doubts or anything like that, we do have tutors standing by. So if you have any questions, we can always drag you to one of the breakup rooms and we can talk to you individually. But other than that, if you have no more questions, I want to this concludes our Happy Math Hour for today. Our next meeting for June 25th is going to be talking about system of equations on the 1324 room. But other than that, if no one has any other questions, this concludes our Happy Math Hour for today. You have a good one, stay safe, and you have a good semester. See you soon, guys.